Hello students, I'm Dr. Gajendra Purohit. Welcome to our channel where I upload videos for engineering, mathematics and B.Sc or any of your competitive exam preparations where higher mathematics is asked. I will present graph theory concept on my channel, which I am sure you will find very helpful. What is a binary tree? What is a tree? What is a spanning tree? What is a pendant vertex? I have many more concepts to share with all of you. So pay attention. We will talk about the tree first. See, what is the difference between a tree and a graph? A graph can be a closed one. A graph can also be described as a circuit type. So, the concept of closeness doesn't apply to trees. This means that whatever graph we have will neither be closed nor circuit. Look, understand the concept. A tree is a connected graph without any loop or circuit. Observe, these are several examples of tree. This is a tree, 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 and this is a tree. Now observe if this occurs here by chance. I would say that if this connects from here like this, then what will happen in this case? Here what's happening is we are getting a closed circuit. So we will have a graph, but this will not be a tree, right? Keep this in mind. For tree, we should not have a closed one. So these are the examples of tree. Can we move further? What is the root of a tree or rooted tree? Root means understanding the origin. Where does it originate from? When we have this type of graph, we can choose either this root or this root, right? Now consider this example. You can see that there are two edges coming from this vertex. Therefore, this vertex will be the root. Here, students, you can observe that three edges extend from this vertex. What will it be? It will be the root. Okay. So, what we have here is the root of a tree. Let's move ahead. We will talk about a binary tree. A binary tree is defined as a tree in which there is exactly one vertex of degree 2. This means that we must have one vertex whose degree is 2 and all other vertices that we have, their degree will either be 1 or 3. Now, whatever has a degree 2, it is always called as the root. And each of the remaining vertices of degree 1 or 3 and vertex of degree 2 are known as a root. Let's see an example. Here we have this. We know that this is a degree 2 vertex. And the degree of the remaining vertex we have is 1. Talking about this, its degree is 2. Its degree is 3. Its degree is 1. Its degree is 1. Its degree is 3. It's 1, 3, 1, 1, right? We have a root and its degree here is 2. The remaining degree, what should it be? It should be either 1 or 3. This is called a binary tree. Now look at this counter example. So what is the degree of these edges? Pay attention here. If we talk about this, its degree is 2. Here its degree is also 2. What's the rule? It is that we should have this degree 2 and the remaining degrees should be 1 and 3. But here we have 2. So that's why this is not a binary tree. Clear? Moving on. We will discuss pendant vertex in tree. What is a pendant vertex? A vertex of degree 1 is called a pendant vertex. We have a tree here. In the tree, among its vertices, those with a degree of 1 are called pendant vertices. For example, the V pendant vertex's degree is 1. The X pendant vertex's degree is 1. And the Y pendant vertex's degree is 1, right? We need to pay attention to this. We will talk about the path length of a tree. What is path length of tree? So the root here, its path length of a tree is defined as the sum of distances from a pendant vertex to all other vertices it connects to. Is it clear? Understand the definition. A path length of a tree is defined as the sum of edges from the root of all pendant vertices. Let's take an example. Let's say that we have a tree here. Now, what do we need to do with it? So, we need to calculate its path length. This vertex is a pendant. If we calculate its distance, it is 1 and 1. So, the total distance is 2. Let's write 2 here. Then if we consider this pendant vertex, the distance is also 2. If we take it from this pendant vertex, then this is also 2. From this pendant vertex 1, 2 and 3. So, here is 3. So, from this pendant vertex, we'll take 1, 2, 3, right? If we calculate the total of this, add 6, 3, 9 and 2, 3, so it's 12, right? So, we have the path length here. Students, listen, please correct this. It is indeed 12. Clear? Let's proceed. Let's discuss the spanning tree concept. It's a good topic, featured in exams with many questions. If we are given any type of graph, all the graphs that are in the form of a tree, what do we call them? They are called spanning trees. Did you understand this? Let's see the definition now. So the definition states that if G is any connected graph, a spanning tree in G is a subgraph T of G, which is a tree. Is it clear? So next, we need to remove the subgraphs from here. Is that clear? All those subgraphs should be in the form of a tree. Then what are they called? So they are called as the spanning tree. I will try to explain the concept, okay? For example, this is given and we have to find the spanning tree. Now what will happen here? Pay attention. Let's consider this scenario. We have one possibility, right? This is its subgraph. If I approach this similarly, this could be a subgraph. What I am explaining is that this can also serve as a subgraph. What else can we have if we talk further? Okay, students, I want to explain that these configurations could also potentially exist. And this could also be with us like this, right? What could this be? It is a subgraph, right? If we acquire the next one, it may become available to us. There's one from above, we'll have it from below. This subgraph can be available and this can also be there. Then we can have this one and this one as well. So these are the examples, right? All of these are available here. And what are these? These will be subgraphs and they are called spanning tree. I will tell you a question. Draw a complete graph of 4 vertices and find the spanning tree in this graph. You have to draw a complete graph with 4 vertices here. After that, how many spanning tree will be there? You need to tell the possibilities. Now, here what we will do. So, first of all, we will talk about the 4 vertices, which we have a complete graph like this type, right? Now we know how many subgraphs we can have from this and how many spanning tree we can have as well. Let's take an example and understand things one by one. We have one here. It will be this, right? So, whatever tree we will draw, it should not be closed. If it is closed, then it will not be a tree. This requires attention, correct? So, let's focus on this. What could this be that we have here? Yes, we can have this corner. Hold this corner. What will happen? This will happen. Next, we will hold this corner. So, we have this, don't we? Next, what could we have? Listen, it could be this, right? Next, we can have this one. Clear? Afterwards, we can also have another one. Another one we have is this, right? Now, next, we will move on. We have this one here. We have this one. Is it correct? Furthermore, we can obtain another one like this. Can we have any other? I have already done this one. We can also acquire another one like this. Okay. We have these many spanning tree. How many are there? 2, 2, 4, 2, 6, 2, 8. 2, 10 and 2, 12. So in total, we have 12 spanning tree. So these are the methods available to us for finding a spanning tree of a given graph. Then we will talk about this theorem, which is highly significant and its proof is occasionally asked in exams. The question is to demonstrate that there is only one path between every pair of vertices in the tree. So in the tree, we are told that there is only one path that connects the vertices, right? If there are multiple paths, then we will have a loop. And if there is a loop, it will not be a tree. So we all know this, okay? If I draw a graph here, imagine it connects this point to this one, and then it connects to this one, and it connects this. Clear? Now it's saying that for any 2 vertices we have, there will be only one path connecting them. If I connected this by drawing this here, then how many paths we have to connect this? One is this and the other one is connecting to this. So we have 2 paths. So what happens here? It's not a tree because for a tree to happen, we should not have loop. But see here we have a loop. Now this is already visible to us. So ultimately the proof will be this. Suppose that there are 2 paths between vertices u and v. Then the union of these 2 paths will be contained in a circuit. So T cannot be the tree. If there is a circuit and it is closed, then we won't have the tree. Hence, there is only one path between every pair of vertices in the tree, T. Okay. So in this way, we can understand it. Next, we will discuss this. Prove that a tree with n vertices has n minus 1 edges. Is it clear? So if we have n vertices, then the number of edges it has will be n minus 1. We will work on this concept and we will prove it with the help of mathematical induction. What is it? Pay attention. Let's see what we will do here first. We take n is equal to 1. We know that if we take 1, we'll have 1 vertex and there will be no edges. If we take n and keep n is equal to 1, then this is 0 edge. So if 1 is vertex, then 0 is edge. And we absolutely have tree. If we take n equals to 2 here, that means we take 2 vertices. So to connect these 2 vertices, we will have 1 edge, right? N minus 1. If we put 2 in place of n, then we'll get 1 edge. If we take n is equal to 3, then we will have this and this, right? So we will need 2 edges to connect these 3 vertices. There cannot be 3 edges if we try to draw third edge. Then this won't be a tree. This will be a graph, a closed circuit. We will keep n equal to 3, then 3 minus 1 is 2. So it fits perfectly. By the mathematical induction, this theorem is hold for all trees with n vertices. So in this way, we can easily prove it here. Next question, find the path length of tree. You are given this tree and you have to find its path length. So what do? We take the distance from the root to the pendant vertex. We will calculate the distance of all the pendant vertices. This is one pendant vertex. From here, its distance will be 1, 2. For this pendant vertex, distance from here is 1, 2, 3, right? Then if we will calculate it from here, this will come 1, 2, 3. For this, we'll take from here, so 1, 2, and 3. So then we will calculate it from here, so 1, 2, and 3. And then we will calculate it from here, so 1, 2, right? How much is it? 3, 3, and 3. This is 12, 13, 14, 15, 16. So what will be the path length? So it will be 16. In this way, we can easily solve this. Moving forward, so you have to answer this question in the comment box, and please do tell me how much time it took you to solve this. The content I've included for discrete math in all my graph theory videos is quite good. You can check it out in my new channel. I am uploading a lot of short tricks. If you are preparing for CSIR, NET, GATE, IIT-JAM or any other competitive exam, check the short tricks. You can subscribe to my channel and follow me on Instagram. Thank you so much for watching. Please like, share and subscribe to the channel. Please provide answer in comment box. Thank you.